Now we're going to look at Charles's law. Charles's law comes from Jacques Charles, a French scientist back in 1787, who decided that maybe, just maybe, volume and temperature had something to do with each other. So he was sitting around his house, kind of like what we're all doing, and he decided he was going to use a can to test his theory at two different temperatures. So here we have the modern version. We have a can heating up and a bowl of ice water to provide our cold temperature. All right, we have our can that's been heating up in our boiling water, and we're going to try and crush it using just the power of changing the temperature. So hopefully that water vapor inside the can needs to be heated all the way up. Let's see if we can do it. Woo! That was quick. So, we're back here with our can crushed by Charles's law. We related volume to temperature, but you'll notice that it crushed, which means maybe it had something to do with pressure too. You remember pressure from Boyle's law. Seems like they're all related. And if we think about kinetic molecular theory, when the gas was heated, those particles were moving really fast, pressing on all the walls of the can, keeping it expanded. And then when we closed off, so we had the same number of molecules in the can, but the temperature cooled, it started to condense those molecules, just like in our Cartesian diver. The molecules became more dense, so they weren't pressing on the walls anymore, and the can imploded. So Charles's law was pretty fun, and I wanted to show you Charles' law going in the other direction. So we're going to start with a relatively cool object, this bar of soap. And this bar of soap is a little bit special because it's a whipped soap. And whipped means that it has a bunch of air bubbles in it. So all those tiny air bubbles give us tiny pockets of gas that we can then heat up in the microwave. So what do you think's going to happen? Right, here I have our bar of whipped soap, and I'm going to put it in a microwave-safe bowl. And I'm going to put it in the microwave for 2 minutes so we can heat it up and see what happens. So we gave our soap 2 minutes in the microwave, and I'm going to open it up, and it definitely got a little hot. So I'm going to carefully take it out of the microwave oven and show you. It smells great too. Now as it cools, it's going to shrink just a little bit, and you can touch it, but you want to wait until it cools down a little bit. So I'm going to give it about 2 minutes to cool off before we take a closer look. All right, so here's our cooled and fluffy soap, and you can pick it up. It's pretty crumbly. It's super fluffy because all of those air bubbles expanded. Ooh, it's like a cotton ball almost. And it still cleans like soap, so you can definitely still use this if you make it at home. One of the fun things you can do with it is add a cup of hot water, and then you can add about a roll, well, half a roll to a roll of toilet paper, a little bit at a time, and you can make clean clay, which is kind of like clay, but it's soap. And because you use toilet paper, it's totally biodegradable, so it can go down the drain. And that can be fun to model into cute shapes. So yeah, there's Charles's Law.